A little over 100 instructions. That's what it boils down to. Everything you write in 40H consists of a combination of these 100 fundamental instructions. If you are a C developer and want to add more instructions, you can. Up to 256 different instructions. That's it. That's the limit. It's a limited resource. That means I have to reuse as many tokens as possible, and that's why 40H's I/O system is the way it is. It's incredibly efficient in that regard. But I can't take all the praise for that. If you want to be good, you have to nick an idea here and there. And like so many things, this design originates in one of the most humble machines in existence. A British 8-bit home computer from the 80s called the ZX Spectrum. It actually was my first computer, and through the years I added many modifications. It hardly resembled the original machine anymore. I had added two 5¼ floppy disk drives, an RGB monitor, an 80-column matrix printer, a programmable joystick interface, and a full-size keyboard. The original power supply wasn't able to sustain this wild array of extensions, so the entire circuitry had been ripped out and replaced by a set of 3 different power supplies. One for 5 volts, one for 9 volts, and one for 12 volts. In today's money, that setup, corrected for inflation, amounts to 14,000 euros, or over 15,000 US dollars. I was quite attached to the little machine and used it until the early 1990s. But I digress. Now, where did I look for a solution for 40H I/O problem? To my good old Specky, of course. Now, the Spectrum had devices like a keyboard, a screen, and sometimes even a printer. These were called channels and were identified by a single letter. And you had bit streams that were coming from or going to these devices. These were called streams and identified by a number. Now, the fun part is that some keywords were connected to the streams, like lprint was connected to the stream assigned to the printer, and print was connected to the stream assigned to the keyboard. But you could reroute those streams by using the open keyword. For instance, open stream 2 to the printer, rerouted all the output from the screen to the printer, essentially turning print to lprint. So when designing Ford I/O system, I took a few of these concepts and ran with them. What I did was to abstract this Spectrum channels idea a little further. So only 2 channels remained, an input channel and an output channel. Usually, Ford supports 8 streams, of which 6 can be defined by the user himself. The other 2 are taken by the system. Standard in, which is assigned to the keyboard, and standard out, which is assigned to the screen. The open word creates a new stream. In this case, an output file named outfile.txt. The word input combined with the word open creates an input stream, in this case a file named infile.txt. In both cases, a stream number is put on the stack. But note, nothing changes. Output is still going to the screen. The word use changes that. If you issue it with the correct stream number, it is assigned to the appropriate channel. Note that we already provided the channel information when we opened the stream. When we apply close to a valid stream, that stream is closed and invalidated. If the channel is still connected to the stream, it is reassigned to the default stream, in this case standard out. If close is applied to an inactive stream, that stream is closed and invalidated, but nothing else happens. If there's a user-defined stream attached to that channel, it remains attached to that channel. And note how all I/O related words are bound to those channels, and not the streams. Emit, type, quote, they all use the output channel. Refill and accept, they all use the input channel. Of course, it doesn't mean that I/O is performed from a myriad of places. Output is performed by a function in the 40H VM called emit, and input is performed by a function called accept. The former contains a single call to fputC, and the latter a call to fgetC, and that's basically the entire 40H I/O system. That was C, not Ford. I'm so sorry. Worse, it's not over yet. Because the accept function is really clever, if I may say so myself. It has two modes, text mode and a binary mode. If you use accept to directly enter text from the keyboard using the forward word accept, it will either read up to the maximum number of characters or terminate on the first enter. It will also properly terminate the string. However, if you use accept to read a file, it will fill your buffer with the designated number of characters. And that's it. No termination, no translations. Therefore, accept is the designated word to read a binary file. In C, you have to declare whether you open a file as a binary file or as a text file. In 40H, there is no such thing. If you treat the file like a binary file, it will behave as a binary file. If you treat it as a text file, it will behave as a text file. The basic way to read the text file is to use refill. Refill will read a line from the file and put it in the terminal input buffer, aka tip. Technically, you can access that line, since you can freely access the tip, but the recommended way is to use parse. Parse takes a delimiter and returns an address and a count from a previous parse up to the next delimiter. If that line belongs to a well-behaved comma-separated values file, you can parse the entire line that way. If you want a complete line, just issue 0 parse, no sweat. The underline accept function is so smart that you can read almost every text file under the sun without a hitch, no matter whether it is a Microsoft text file, a Unix text file, or an old Apple text file. To 40H, a line is a line is a line. I can't make it any simpler than that. It should be perfectly clear that this is not the way ANS FILE approaches files. I must admit I'm not a fan of this word set.
And very evidently so.
It gives me C vibes. Let me be clear. I got nothing against C. It's a wonderful language which I still use from time to time, but it's the result of an entirely different philosophy, and that philosophy is not forward. In my humble opinion, the whole word set feels bolted on.
Weird.
On the other hand, it's a standard. If we want to come together and use each other programs, we need that standard. And believe me or not, 40H is not the only Ford with its own I/O system. Other Fords took the same approach and translated their own I/O API to the ANS Ford API. And so did 40H. What it basically does is save its own current channel assignments, perform the I/O requested, and then restore those channel assignments. So yes, I don't recommend it, but you can mix native I/O and ANS Ford I/O in the same program. Can't say I use it very often for the reason I just mentioned, but when I don't feel like converting the I/O of an ANS Ford program, this little library is a real lifesaver. True, you had to wait over a month for a new episode, but you know, in order to make them, you have to keep on programming. And that's exactly what I've been doing, folks. Encryption, sorting routines, random number generators, complex numbers, the whole enchilada. And ending on that positive note, I'm Hans Bezemer, and this was Back and Forth.
Weird.